All right. This is about what happens when you use your muscles. We call it a muscle twitch. And you may have experienced little muscle twitches in your face, but really all of your muscle contractions are twitches. Your muscle can't do a little bit of a pull. When you tell myosin, or when you move those fibers, myosin doesn't pull just a little bit. If you let it pull, it's going to pull as fast and as hard as it possibly can. So that's why we call it a twitch, because it's a really rapid grab pull kind of movement. So at the bottom of page 5, just draw in a little kind of a graph like this. And if this is your muscle tone, that's how much your muscles flexed at relaxation. When you tell that muscle to fire, it's going to twitch. It's going to have more tension, and then it will start to relax. And you can't tell it to do more or less than that. At least that one fiber, that's all it can do. So if we're talking about wanting to have a stronger contraction in a single muscle fiber, the only way to do it is through a process called summation. And summation, meaning like add, means we're going to add a bunch of these twitches together. So we're going to add that first twitch. It looks very similar so far to the first one. But before it gets fully relaxed, we're going to tell it to twitch again. And now it gets even a little bit shorter, a little bit more force. And before that one ends, we're going to tell it to twitch again. And then between that one again. And you could even speed these up even more, and that will continue to increase faster. Now at some point that muscle will reach its maximum, the most force that muscle fiber can do. And eventually, no matter how much faster you send those signals, it will just kind of flatten out here and not change too much. So we should label this. This is the force being exerted here. So this would just be a twitch or a stimulus. I guess we could put an arrow here to say, so this is where the stimulus was. And there's probably a little bit of a delay there, but that's not a huge deal. This rising we would call summation. And at the top, when the muscle is completely just smoothed out, you can't get any more out of it, that's called tetanus. Now, not the disease tetanus, but that just means muscle tetanus when they're fully contracted. Oddly enough, well, not oddly enough, but the disease tetanus that you maybe have had a tetanus shot for is you can get an infection that causes your muscles to go into tetanus. They lock up. You may have heard of lockjaw, where the muscles of the face lock up. You can't open your mouth anymore. That's part of this. So they call the disease tetanus. Don't get the disease tetanus confused, though, with this muscle tetanus, which is just a whole bunch of contractions. So this is for one fiber. If you want it to twitch stronger, you can tell it to twitch more frequently, and that strength will get higher and higher. Now, if you also want to get a stronger strength of contraction, there are other ways we can do it as well. So the first one is, we just talked about, is the frequency of stimulation, right? And that's what we just drew this graph. I stimulate it more, it will get stronger. But we were talking about a single muscle fiber. In all of the muscles in your body, you have more than one fiber. So the other way that you can get a stronger contraction is from the number of fibers stimulated. So if I have 20 muscle fibers, if I want to contract that muscle as hard as I can, I'm probably going to tell all 20 to contract. But if you want to pick up something and it's very delicate, like if I want to pick up my son at home, I don't want to flex all of my muscle fibers because I'd probably cause some damage and hurt him. So we need to be able to coordinate whether we're squeezing something hard or soft or touching something gently. Your brain is doing all of that coordination by deciding how often do I want to tell those fibers to twitch, and how many fibers do I want to twitch. So if you're doing something very lightly, you may only be using just a very few fibers in that muscle. But if you grab a heavy object and try to lift it, you're going to be doing both of these things a little bit more frequently and a little bit and more fibers stimulating all together. All right, last thing for the motor system. There are 3 different types of muscle fibers, and we're not going to get too into them as much. There's 2 that you need to know for sure. There's type 1 fibers, and there are type 2 fibers. And in the type 2, there's 2 different types we'll look at. We're not going to get super picky about that. But type 1 fibers are slow. These are a muscle fiber type that doesn't contract very quickly. Their advantage, though, is they don't fatigue very easily. They resist fatigue. So they don't get tired very easily. They may not be as strong or as fast, but they will be able to do their job for a longer period of time. So these usually also have lots of mitochondria. So they're really good at that aerobic cellular respiration. They typically have a darker color because of a pigment in them called myoglobin. We're going to learn about hemoglobin when we do the circulatory system that carries oxygen. Myoglobin, let me write that in here, is a molecule that you have. Globic? What am I talking about? Myoglobin. And what it does is it carries oxygen. So it holds oxygen in the muscles so that that oxygen is there and ready for use. And they also tend to have a larger storage of things like glycogen and fats and those kinds of things. Okay. Type 2 fibers are in many ways the opposite. These are very fast. These are very strong. They fatigue much easier. They don't have as many mitochondria, so fewer. Probably not as much glycogen and myoglobin stored there. So they tend to have a lighter color because of the lack of those pigments, less blood flow and things that are there. And probably lower storage. Now in your notes, it also talks about that there are type 2A, which are fast fibers, and type 2X, which are very fast fibers. I'm not going to test you too much on, or any probably at all on that. Just know type 1 is a slow twitch muscle, really good for things like endurance running. Like if you're a long distance runner, cross country, something like that, the type of muscle you want to train is this one. Now, it doesn't mean you only have one or the other. If we took any one of your muscles, you probably have both of these in there. But depending on the exercise you do, you train those muscle fibers. So if you go for a long distance run, you're training your type 1 muscle fibers. If you go and lift really heavy weights or run sprints, then you're training those type 2 muscle fibers to get stronger. And so you can, depending on the type of exercise you do, you train these muscle fibers separately because they're a different system. The easiest way to talk about this, if you think about the last time you had a turkey dinner, type 1 muscle is dark meat. It's the parts of the turkey or the chicken or whatever you may have eaten that they don't have to move very quickly, so they tend to be a little slower, but they have lots of mitochondria. They're good at like walking or things like that. This is like the drumstick on a chicken. If you want type 2 muscle, you want the white meat. Typically on something like a turkey or a chicken, that's like the breast breast meat, those muscles, like the pectoral muscles of the bird, because they need to move very fast. The chickens, like to fly, have to flap their wings very, very rapidly. So that's a fast type of muscle. Whereas if you had something like a goose or a duck, they fly long distances. So when they flap their wings, they don't flap them very fast necessarily all the time. They're kind of a slower, long distance endurance type. So that muscle is probably not as a white meat-y as like a turkey would be. It would probably be more like the dark meat that you would get from a turkey if you were to eat duck or goose or something like that. So those are the two types of fibers. Hopefully that makes sense. Hopefully you understand how the muscle twitch works. And that finishes it off for the motor system. So this is it for what you need to know for muscles. If you have any questions about anything, please let me know. We'll start into the circulatory system probably tomorrow. I'll start sending some videos. I'm working from home right now, so that's why the video is a little bit different. But if you have any questions or anything, just let me know and I'll get back to you as soon as I can.